Hello everyone. February the 10th. Let's get it going. Remove all occurrences of a substring. Two strings S and part. Perform the following operation on S until all occurrences of the substring part are removed. Find the leftmost occurrences of the substring part and then remove it from S. Return S after all occurrences of part have been removed. Okay. That feels like, I don't know. D, A, B, C. So we need to know when a part shows up. Well, we can, let's say, compare the substring, the last, every time we add it, and then we compare the last with the part. I don't know if that's a good way. But the length is 1000, so I think it's possible. So basically, each time we add, we compare. Each time we add, we compare. And if it's good, I will... Actually, I mean, we don't even need to use I can just use pointers, right? B, A, B, C, B, C. Yeah, we can just say, you know, pointing here, pointing here, pointing here, pointing here. And then we can do a check. Oh, we just start here, we do a check. Doesn't work, doesn't work. Works, so we remove, basically we move this one to here, right? So we have a front and a back. Front just keep moving on. Back is, I'm gonna say, this is I, this is J. J keep moving forward. Ooh, but, oh yeah, it's fine, right? J move forward. I will also move forward, and I will just swap, and then, okay. O(n) squared. For J, S dot size, part dot size. Yeah, I don't need this. Alright, J just keep moving forward. So for each one we need to check. I will. So I need to point into the one that hasn't been visited yet. Okay, so basically J move forward. I is pointing to the next position. So J move forward, and I will swap first. Okay, so I say S I will equal to Sj. Okay, and then we say if I is because I swap it and I is the 1, right? So if it's 0, 1, 2, and say it's larger or equal to n minus 1, then we'll check if the suffix matches part. How do we check? For int k equal to I minus m plus 1, k smaller equal to I, k plus plus. Okay, and matches, boolean matches. Oh. If sk is not equal to part I plus m minus 1. Oh my goodness. Then we say matches equal to false, and I'll break. Right, I say if matches, then we move I to the front, right? Because I minus m plus 1 is the starting position, so we move there. That is where I should be. That's where I should be. But at the end, I think every time, so I move it, I should move forward. So regardless, I'll plus plus. So in this case, I shall move to this position, I minus m. So plus plus will point forward. So I might as well just say minus equal. Else, if it's not the same, then we don't do anything. Okay. All right. So we do this at the end. J is done, and I will plus plus. Okay. I plus plus. I is ending at the end. So can I say string res, let's say s dot begin and s dot begin plus I. Now return res, or maybe s dot substring. Star is 0 and I. Maybe this one will be better. Okay. Okay. Looks solid. Use stack. But we implement it in place with pointers, with indices. Maybe there are some edge cases I didn't know. Totally passable. Totally passable. Possible. Alright, we'll try it. If it doesn't work, then we work on it. But turns out it works. Pretty simple. September 18th, 2022. Iteration 1 squared divided by m. Oh wow. Okay. Stack. Oh, KMP. Jeez. Oh, this is just to find substring. But then I have to find substring, then what? Oh, I see. KMP just used to match. Ah, I see. Pattern index. This is not how I imagine it to be. It is when it's not the same, then what you do is you go back one and then you use KMP to immediately know that match here, right? Because the idea is previous one match, so you can jump forward. Hold a second, I kind of forgot how it's done. So basically, you have the pattern, yeah, the suffix, maximum suffix prefix sum, prefix match, right? So basically we say how much it match in a suffix. Ending a here, how much? Okay, yeah, I know how that array works. So when we have a match, we move forward. If we have a mismatch, then we go to the previous one, and the previous one will tell me where I need to start matching. Okay. Yep, okay. I kind of rearranged my brain. Okay, so we have K and PLPS. Longest prefix suffix, okay. This is this array to store pattern matching indices during traversal. What the hell is this? Pattern indices. Pattern matching indices. Okay, so we have str index, pattern index. Alright, so if the current char is equal to part pattern index, so pattern index is the index in the pattern, right? So if these two are the same, then you go for the next one. Pattern index char stack dot size. The next pattern index when characters match. So this is the next pattern index for the char. So for the next one, the pattern index need to plus plus. That's what we need to go. Okay, makes sense. If pattern index is equal to part.length, which means we have matched the entire pattern, then we need to pop, right? We need to pop until we get everything. Okay, this is understandable. What's this? Pattern index. When they restore pattern index, so it's if char stack is empty, they'll hold this. Okay, if it's not empty, then pattern index basically means which index does the char stack match the pattern index, match the pattern, and as the char, so the char stack dot size, which means when the char stacks at this position, which pattern, which index in the pattern do you match? Right, this is the next potential match. This is also the next potential match. So the next round come along, and then we have this pattern index. Pattern index is what it needs to match. For the next round, because if the char stack is not empty, then its size will be the next pattern index. I'm not quite sure though, because this you just keep popping, right? So once you pop, you removed everyone, and then you say pattern index char dot size. Oh, this is why. For next potential match. Next potential match. Because remember, this one is immediately. Yeah, you immediately need to compare the part. This is just saying which part we need to compare. Right? Which part we need to compare. And we say we need to compare using the next one? This doesn't make any sense to me. This part a little bit hard to parse. Let me think one more time. So pattern indices, right? It basically says at each char stack position, what is the index in the pattern that is supposed to be matching, right? And it makes perfect sense when we start, right? It says if it's equal, then the current position will be, no, this is the next position, you will go for this, right? And then this is saying if everything is matching, then I need to pop. Okay, now I pop. After I pop everything, if I still have char stack, okay, then we need the next one. It makes sense. Okay, makes sense. Makes sense. Make perfect sense. Yes, because the next one originally was a match. So you can go to the pattern indices for the next char stack to get the next pattern. You need to be matching. Okay, this part is good, and this part does not require the KMP. This is when we need KMP, right? Because this is if the current does not match, right? If the current does not match, then we need to go one position back, which is what we do this. We go one position back and we use KMP to get, okay, hold a second. If pattern index is not equal to 0, so we are matching somewhere in it, right? So we're matching this, and then it says it does not match. So pattern index minus 1, KMP LPS, this will give me the length of the prefix suffix match, right? And then I will reset the pattern index to that value. Exactly. This is right. Yeah, this is the jewel of this. It's KMP LPS pattern index minus 1 will return the length of the matching prefix, right? No, the prefix that's matching the current suffix, the length. So that will be your pattern index for the next round of matching. And I need to pop the char stack because I put something in the char stack before. So I pop it, this is good. Now if pattern index is 0, well, if pattern index is 0, that means the current is not matching, so we need to reset, which you just reset it to 0. It's fine. Okay, yeah, so essentially we're using KMP to make the matching a little bit faster. Right, a little bit faster. But boy, who's gonna do that? We might as well go through this one more time. So this is the pattern. We need to build the prefix suffix on the pattern, right? So if, how do we even build this pattern? Prefix suffix. So if the current, we have a prefix length, yes. So if the current is equal to the prefix length, so if current is equal to the pattern prefix length, right? Pattern prefix length and current, if it's good, and then your LPS for this position just prefix length plus, and then current move forward, prefix length also, yeah. Once you hit a mismatch, right? And then, because I want to know where is the matching for this. So I go to the previous, I use LPS already computed. So that will be the next current. Yeah, that will be the next current, will be LPS. Well, of course, they have to check the prefix length. If prefix length is not equal to 0, so the prefix length is not equal to 0, so LPS prefix minus 1 will be the new prefix length. Yes, that's the new prefix length. And what about current? Oh, it's fine. Current, you'll compare again. Yes, you'll compare it again. And if it becomes 0, which means nobody is matching, right? Prefix length, it becomes 0. Now when the prefix length becomes 0, then we need to update the LPS for this current position. It's going to be 0, which means nothing prefix will be equal to this, right? And then we move on. Yeah, that makes sense. It does make sense, right? It does make sense. I'm just not sure if it's good. Just go through KMP once in a while, and it helps. All right. Anyway, that will be it for today. Didn't expect to see KMP here, but yeah, it's a positive. It's a good surprise. All right. All right. I'll see you guys tomorrow. Adios.